Hi children and hi everyone. In this class I am going to explain about the interfirst year second chapter units and measurements. Units and measurements. So in this chapter you may learn types of errors, what is accuracy, what is precision, and how many types of errors there. So we will see in this chapter. So in this video especially I hope that you may learn accuracy, about the accuracy, precision and types of error, children. So after watching this video you must like the video, share the video and comment the video. Children, I am going to the topic now here. Errors. Here chapter name is what? Units and measurements. Here now in our classes we may do some experiments. So in that experiments what we take? Measurements. In that measurements, is there any error? If any error there, how we can find out that and how we can eliminate that? In daily life also, once you go to your any tailor, first they will take measurements of your body, measurements to stitch shirt or pant, anything that they will collect some measurements. So to prepare a bench, to prepare a table, and for this board also some dimensions are there. For that also some measurements will be there. So for fan, for light some holder is there. For holder and bulb both are having some measurements. So the measurements is very necessary in our daily life. You can take any one thing. In our mobile also you will take some pictures. In that editing also you will take some size of the pictures. So that means in daily life measurements are related to our life, very close to us, but we don't know that. Wheels of the vehicle have some measurements, at least steering of the car and handle of the bike, and it is every engine is made up of so many screws. So for them also measurement is there. That's why in our daily life measurements will play very crucial role. So by manufacturing or constructing the different type of objects, we will have to take some measurements. So during that taking measurements, is there any possibility of having errors? So I am going to topic now here. In this topic, first you must know about this one, accuracy and precision. What is mean by accuracy? What is mean by accuracy? Here accuracy means that, for example, we are doing one experiment. That experiment is finding the acceleration due to gravity, where by using simple pendulum we want to find out the g value. G means what? Acceleration due to gravity. So its value is what? Its value is constant. We know that 9.8 meter per second square. So g value is what? 9.8 meter per second square. Got, children? So for example here some 3 people are there, same experiment we are given to 5 students, some A, B, C, D and E. We distributed apparatus to the 5 students separately. They are calculating G value. So after completion of exam they conclude that the value what they find. So for example here A calculated, that should be here 9.5, and B calculated 9.3, and C is calculated as 9.4, and D is calculated some 8.5, and E is 9.6. So the student E calculated is 9.6 meter per second square. Clear? The students perform one activity, one experiment. We gave finding the simple pendulum experiment is there, finding the acceleration due to gravity by using some simple pendulum. That is the experiment we are given. Already we know that the value of G is what? 9.8 meter per second square. So we have to verify the experiment by doing some activity, by experiment in our laboratory. So for that I gave, we have 5 students are there, I gave favorite test to the 5 students. They performed one activity and they should be measured with the value of G. A should be measured as, note that it is 9.5 and B is 9.3, C is 9.4 and D is 8.5 and E is 9.6. So here in those 5 students, while observing all the values, in these values which one is very close to the true value? This 9.8 is what? True value. Here in that 9.8, which value is very near to 9.8? Yes, this value E is equals to 9.6 meter per second square. Here among these 5 students, this value is very close to the student who is E. He was measured the value 9.6, that 9.6 is close to the 9.8. 9.8. That's why here what I have to say, in this case we have to say that the student A is performed experiment accurately. The student E is performed accurately. That means what? The measured value is closeness to the true value. That means the accuracy is nothing but in measured values, the value which is how much it is close to the true value, that will say the accuracy. Accuracy is means that the measured value how much it is very close to the true value, that is the accuracy. So in this experiment the student E performed his experiment very accurately, because among these fellows only one fellow is very close to the 9.8 meter per second square. The 9.8 meter per second square is taken as the true value. Accuracy means is that, what is that? Accuracy means that the measured value which is very nearest to the true value. The measured value how much close to the true value is called accuracy. Clear, children? So now we go for precision. What is that? Precision. So here now one glass slab is there. What's that? We are going for another experiment now. This is the glass slab. Glass slab. Clear? One student is doing one experiment. What is that? He want to find out the length. You want to find out the length by using different instruments. Clear, children? So here we are giving first thing is ordinary scale. What is that? Ordinary scale. Next thing is vernier calipers. What is that? Vernier calipers. And third one is screw gauge. So you may find them in laboratory. Ordinary scale, vernier calipers and screw gauge. Clear? So up to now, what is the least value measured by using ordinary scale? In an ordinary scale here you can observe that. So here starting is 0, then after 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10 lines we have 1. That means each one is how much? 1 millimeter. What's that? In an ordinary scale, after 10 lines we have 1. That means what? 1 by 10. That means 0.1 centimeter. What's that? 0.1 centimeter. For 1 millimeter is equals to, here I am writing 0.1 centimeter. For vernier calipers, each division is 0.01 centimeters. Clear? And now this one is 0.001 centimeter. Got, children? Here 1 millimeter is equals to here 0.1 centimeter. Don't confuse, very interesting here. only one glass slab it is there. The activity what was given, the activity is finding the length of the glass plate or glass slab by using different instruments. Clear? Now here first time we have measured ordinary by using ordinary scale. Then the value should be measured as some 4.8. Next time here, by repeating the same thing with the vernier calipers, we may find some 4.75. If you can do the same thing by using the screw gauge, we will get 4.632. Clear? Same thing here. To understand about the precision, you have to observe this experiment. Clear, children? So this is the one glass plate. This is what? Glass plate. So this is the glass plate, it is there. We want to find out the length by using different instruments. The first thing is here what? Ordinary scale. By using ordinary scale, what is the least value we have to measure? 1 millimeter. Simply 1. Each one is 1 millimeter. So here now, by using ordinary scale, we are having 1 millimeter. That means 0.1 centimeter. By using vernier calipers, we can measure up to 0.01 centimeter. 0.01 centimeter. And by using screw gauge, 0.001 centimeters. So by taking the different instruments, after conducting the experiment, we are getting the value should be like this. For ordinary scale, 4.8. For vernier calipers, 4.75. And for screw gauge, 4.632. 632. That means here in this case, which is having more precision? This only 4.6.32. After decimal point up to 3 digits. After decimal point up to 3 digits, we can measure the length. That means by using the screw gauge, up to very least value also we can find. So that is the precision. The least value measured by an instrument in an experiment, that should be taken as precision of that instrument. Clear? Precision of that instrument. The least value measured by the one instrument in an experiment should be called as precision. Got, children? So by using the ordinary scale, we will measure up to 1 millimeter. That means 0.1 centimeter. 0.1 centimeter is the precision of ordinary scale. For vernier calipers, 0.01 centimeters. Up to that is we can measure. And for screw gauge, 0.001 centimeters. So this is about the accuracy and precision. Got clear? Accuracy means what? In the measured values, the which value is very close to the true value, that should be called as the accuracy or accurate value, and that should be has more accuracy. And precision means what? The least value measured by the instrument. The least value measured by the instrument in an experiment is called very least value. The least value measured by the instrument in an experiment is called precision. So children, this is about the accuracy and precision. So after that, here we have types of errors there. Types of errors. So now here types of errors. Types of errors means here, I already told you, while we are measuring the experiments or while we are taking the readings, there is some possibility for the some errors. In this case, the errors are divided into two types. Types of errors: systematic error, random error. Clear, children? The errors which are occurred in an experiments, those should be taken as here now. Types of errors here: systematic error and random error. What is mean by error? The uncertainty in value. The uncertainty in value should be called error. Error is divided over here two types: systematic errors and random errors. So here some of the systematic errors there here. Just look here. First thing is instrumental error, imperfection in the experimental error, and personal errors. Errors divided into two types: systematic error, random error. Again, systematic errors should be classified like this: instrumental error, imperfection in experimental technique, and personal errors. Here the first thing is, what is mean by systematic error? What is mean by systematic error? Systematic error is nothing but the errors which are occurred in only one direction. Only one direction. Clear? So those should be called systematic error. The errors which are having in only one direction, either it is positive or negative, that should be taken as the systematic error. The best example for that, the errors which are occurred in vernier calipers and screw gauge, those should be taken as systematic errors. Clear now? So systematic error, the first thing is instrumental error. Instrumental error, when there is some defect in the instrument during the manufacture or calibrating the instrument. For example, if you can take a thermometer, actually what is the value of boiling point of water? 100 degrees Celsius. 100 degrees Celsius. But the thermometer what we are using, that will shows the 104 or 103 or 105 like that. That means what? There is some error in what? Instrument. That is what we call instrumental error. We are having one thermometer. The thermometer shows the, what's that? The reading of boiling point of water is how much? 104 degrees Celsius. But it is wrong. We know that value, what is 100. That means thermometer is has some error. That type of error is called instrumental error. And now in case of the vernier calipers or screw gauge, when in vernier calipers, here zero division of the main scale should be collide with the zero of vernier scale. So once you can observe it, you can saw the any error, I mean any instrument like vernier calipers and screw gauge, then only you may get clarity regarding this. For example, this is the main scale, zero division of the main scale, and this is the zero division of the vernier scale. If both are should be coincide like this, then there is no error in the instrument. Clear? This is the zero division of the main scale and this is the zero division of vernier scale. If both should be coincide like this, then there is no error. For example, if they are like this, they are not coincide, then the error is there. That error is here, maybe it is positive or negative, and if they are not coincide, there is some error for the instrument. You can use that instrument anywhere, you will get the same type of error. That is the another example for instrumental error. The errors which are arised in an experiment by using some instruments due to their improper manufacturing, that should be called here instrumental error. Instrumental error, so the errors are arranged due to the instruments, those are called instrumental error. Example what I told you, thermometer example. And next thing is the errors which are occurred in the vernier calipers and screw gauge are the best example for instrumental error. And next thing is imperfection in experimental technique. Imperfection in experimental technique. For example, here just imagine this is now scale. This is what? Scale. So if you want to find out the length of the anything is, you must be keep like this. So when we can keep like this only, we may get clear value. But if you can keep like this, if you can measure like this, so if you can keep like this, so you will get the clear value. But in class source they will cheat like this, like originally. So if you can, this is the meter scale. After that again you have to keep like this. But how they can measure? They can measure like this. That means what? Some error is there because the scale is not used in proper way. But we want to take the cloth of 3 meters, but after went to outside and again if you can measure that, that should be like 2.9 meters, 2.8 meters. That means what? The experimentally he did some mistake, but by how the error is erased, the scale is not used in proper way. Clear? So if you can measure the scale like this, we are getting perfect reading. If you can take like this, that means if you can take the reading, for example, this is the scale I am showing like this. So I want to measure the length of this one. I am keeping like this. Next like this. This is the right. But if you can do like this, then we are getting the wrong reading. So that means the instrument is not used in a proper way. Clear? So after that, for example, we have another example is there, that is what? Thermometer. So for aged people, for example, the above the some 15 years or 10 years like that, we have to take the temperature, water temperature by inserting the thermometer in our mouth below our tongue. We will take the temperature like that. If you can keep the same thermometer under armpit, then also we are reading some temperature of the body. Generally, how we can take the temperature of the human body? By using the thermometer, by putting into our mouth. So actually, instead of that, if you can keep like this, the thermometer is placed under armpit, then also the temperature will be, we can identify that. But the temperature is must be lesser than the, while we are taking from the, placing the thermometer from in our mouth. That means here we want to find out the temperature of a man. So but we are, instead of putting a thermometer in our mouth, we have kept in armpit. Then we are reading the, we can show that the temperature of the body should be less. That means again the thermometer is not used in a proper way. That's why we are reading that there is what? Imperfection experimental technique. And next thing is personal errors. Personal errors. The errors which are occurred only because of lack of concentration or negligence of the observer. Some errors are erased, those are called personal errors. Personal error. Clear? For example, that best example is parallax error. Parallax means error means what? For example, here while doing the experiments by using the vernier calipers or screw gauge or by taking the reading of thermometer, you have to show in correct manner. Some people will like this, some people like this, some people like this. It is 96. Okay. That means without any lack of concentration, simply we are, with our negligence only some errors are arising. While taking the readings, we must concentrate very concentratedly, but with our negligence simply we can note nothing. For example, in vernier calipers exam, here we observed some 3.56 is there. 3.56 centimeters is there. Simply I am writing now 3.65. The observed value is what? 3.56. By we are observing like this, we are at 3.56. But while we are noting the value 3.65. 3.56 is the actual reading what you observed, but while you was noting 3.65. That means here what it is, there is some negligence is there. Due to that only some errors are erased. That type of errors also called as grass errors. The parallax error and grass error is the best example for personal errors. And next thing is random errors. What is that? Random errors. In your 10th class, you know, we have one experiment is there. What's that? Ohm's law. Verification of Ohm's law. V is equals to IR. So in that experiment, you are doing some, what is that? You want to show that V by I is equals to constant. V by I is equals to constant. In our 10th class, one activity is there, Ohm's law. If you can write like V by I is equals to constant. That means you are doing the experiment by using some voltage battery. Here there is some fluctuations in voltage. Fluctuations. Maybe where we are doing the experiment, there the voltage will be increases suddenly and the voltage may be dropped suddenly. Due to that, the errors are occurred in current values. That type of error is called randomly. We never expect that So when the current will be increased, when the voltage will be increased, when the voltage will be decreased. That type of error is called random error. What's that? Random error. So here for that random error, what you have to say, the heat experiments, the errors occurred in the heat experiment. For example, if you know that calorimeter experiment is there, calorimeter experiment it is there. For example, here now simply we want to find out the temperature of hot water, temperature of hot water. For that simply you are keeping thermometer inside. Clear? If you can see that directly, you make it some clear. But here, if you can keep like this, vessel is there, in that you can put the thermometer. Just you are taken out. When you are taken out, there is some error will be there because the temperature will be changes. The body's thermometer is not contact with water. Simply here, the errors you have to remind clearly, the errors which are occurred in the heat experiments, that is because of random errors. For example, we want to know about the temperature of this room. Clear? So by taking thermometer we can find out the temperature of thermometer. And after that you went to some kitchen. Room. Then you can keep thermometer. Then also we are getting more temperature. In hall we are getting less temperature. But when you went to the kitchen, there is how is operating. That's why the surrounding is more. Then the reading shown by thermometer will be more. That means already some heat is in the kitchen. That's why we are getting the more temperature of the room. That means during that experiment we want to find out the temperature of kitchen. Then obviously some heat is already there. Due to that some temperature will be increases. So these errors are called here random errors. Simply you have to remember that the errors which are occurred in the current experiments and heat experiments, those should be taken as the best examples for the random errors. So children, so this is about the types of errors and accuracy, precision. So I hope that you can understand this one. So if you can understand clearly, you watch the video without skipping. Clear? So I hope you understand. If you can understand this topic, like, share, comment the video, and for latest notifications, and if you want to touch with my videos, for that you can subscribe to my channel and press the bell icon for latest notification. Children, okay children, bye, take care. We will meet in the next video with next topic. Take care, bye.